up, and hopefully we don't have to figure out how to switch him over to the projection mode. And we'll get Steve talking to you about observing in Chile. To Steve Barnes.
Okay. So it's been a while since I've been to the London Centre to give a talk, probably a few years anyway. I've been a little bit busy in the meantime, and a bit of a change in what I've been doing. I used to run a telescope store, and a couple of years ago I stopped doing that and started building observatories in Chile and a few other places. So I'm going to talk tonight mostly about my adventures in Chile, particularly in the Atacama Desert, and I'll talk about some of the projects I've done there, and also some of the observatories I visited in the region there. So here's a light pollution map. Now you guys are, of course, all familiar where we live up here. Here's Chile, is this narrow strip of land along the west coast of South America. This big bright region, that's Santiago. So here's a close-up view. Here's the border along here. So actually Chile is very narrow. It's maybe 300 kilometers sort of in width and 4,500 kilometers long. There's about 15 million people in Chile. About a third of them live in the Santiago region. Just to the north here is about where the desert starts, and then it runs almost all the way through to the north of Chile. Here's a regular map. So when you fly to Chile, you have to actually fly to Santiago. That's the only international airport there. And then we have to take another 2-hour flight back north to just in here. There's a mining town called Calama, and just north of it is the world's second biggest copper mine. It's a big open pit mining. And then where we're set up is just an hour southeast, just outside of a town called San Pedro de Atacama, and we're just about 8 kilometers south of the town. It's about an hour's drive, 2-hour flight here from Santiago, and then an hour's drive, so it's remote but not too bad. This is a Google Earth view of the area. This is the town of San Pedro de Atacama. It's actually a little village of about 2,000 people. And at any one time, there's about that many tourists. San Pedro is a eco-tourist destination. And we're set up, all these sort of brownish areas, this is all actually vegetation. So these are trees. And in the desert, these are oases. So there's there's a river that comes down, and then there's underground water as well that obviously sprouts that life. So so we're in the next oasis down, just on the south edge of it. And here's a zoom in here. When I made the first trip there, I actually didn't know anything about the area, so I did some research on the internet, and I found a French astronomer who was doing tours of the night sky in San Pedro for the tourists who come to there. They take a bus from the town where he has a little sort of tourist storefront, and they come out to his place just south of town. This is his house here, and he gives tours of the night sky, typically 2 or 3 per night, 25 to 30 people in each tour. and his tour lasts about 2 hours. He's really, really good, very good at it. And just before my first trip there, he bought these lodges that were next door to him, and he caters to amateur astronomers that want to come to the southern hemisphere and do some observing. He has telescopes you can rent, you can bring your own. There's power available there, internet. So this is what the desert looks like from the air. So we're coming in. This is just before we get to San Pedro, looking towards the southeast. So here's some of the oases in the background. You know, just a little bit of hazy day. You can hear these are the Andes in the background here. This is a sorry.
They're like the Rockies.
Are you quite high above sea level there?
Yeah, actually, this salt flat area. This is what is this is at 8,000 feet, and the tops of these peaks are all around 20
Do the people there talk in feet?
meters.
Just somehow.
So 20, 24. I use both interchangeably. So if you want to know, so the tops of these peaks are 6,000 meters, and this is about 2,400
Decided
meters.
to compromise on cubits.
Cubits. Okay, there you go. Unfortunately, I grew up with both, and a lot of things I still use feet for. So, yes. So here's the village itself. San Pedro is an ancient town. It's been there for about 3,000 years. It was an important stop on the trade route from the Andes. Today, it's like I said, it's an eco-tourist destination. It doesn't look like much; they're all dirt streets and stuff, but they keep it that way for its charm. Behind, like many of these doors, are restaurants with incredible food. Like I really can't describe it until you go there, but it's probably the highest density of really phenomenal restaurants in the world. It's unbelievable. Here's Alain's lodges. So clouds make good pictures, but this is the exception rather than the rule to see clouds there. There's a big volcano. This one's called Lagoons, so it's just under 6,000 meters at the top. And this is sort of your view from the lodge. Really spectacular place. Here's a daytime shot. This is typically what the sky is like there. They get over 300 clear nights per year. And when I say clear, that's clear dusk till dawn, like no clouds at all during any part of the night. So it's really amazing place. One of the driest places on Earth. So not only is it at altitude at 8,000 feet, but the humidity is typically about 3% there. So. Yeah, because it's so dry, it doesn't feel anywhere near what the temperature is. But in the summertime, you're sort of low 30s, but it feels more like sort of 24, 25.
Typical computer. I'm glad to see that apples do that too.
It's not an apple.
It's just the Apple software.
Just the Apple software.
I wonder, you gave this talk at StarFest last year too, didn't you?
Yes. A similar talk, yes.
Similar talk.
Yeah, I have some added stuff, but yes, some of it is very similar.
You mentioned you don't really feel the heat because the humidity is so low.
Yes.
My question is, do you feel the low humidity? I mean, I've always had a problem with high altitudes. When I go up to mountaintops or whatever, my throat gets really dry and sore throat. And do you feel that?
No, I don't get that. My nose gets very dry, so that's the only thing I really notice there. I don't. You drink lots for sure, and you definitely have to. But no, I can't say I had any other experiences other than really dry nose from it. What's that?
Lots of oxygen?
No, it's reduced. It's just it's a partial pressure thing. So yeah, you get less oxygen
Okay, that's what I.
as you go higher, right?
Yeah, okay.
Yep.
I know what
But 8,000 feet is basically the same pressurization as when you're flying in a commercial jet airplane. So I don't really notice altitude at all at the 8,000 feet. Maybe the first week I'm there, once or twice a day, I'll take an extra breath, that kind of thing. But it's really about it. It's very flat there, so you're not really exerting yourself for walking around or anything either. I'll show some pictures later where we went up to higher altitudes. You definitely feel it there, but at 2,400 meters, most people don't notice it at all. So, so here's a close-up of the volcano. You can just see in the background here. That's about 30 kilometers away from the lodge there. Sarah, that's metric for you.
So the air really is quite clear.
Yes, and this isn't even a particularly great day. On some days, like I went down with a group of Hamilton Center members a year ago, and we had some exceptionally clear days. And the one guy thought, "Oh, I can walk there. It's only 3 or 4 kilometers away." I said, "No, it's not." So.
Now, you're probably going to tell us a lot about the nighttime conditions, but
Yep.
I wanted to ask, are there lots of little communities or
No.
farms with the bright lights like we have in Ontario?
No, not at all. So there's the largest source of light pollution in the area is the zodiacal light. So, that would be your biggest source of light pollution.
And Milky Way, right?
Oh,
And the Milky Way, yeah, for sure. Yeah, there are, and then the next biggest source of light pollution is actually the ALMA project, which is about 40 kilometers away where they're building. I'll show you some pictures of that. But no, light pollution is definitely not a factor there at all.
And are any of the mountains active volcanoes?
Yes, actually. There's one probably 50, 60 kilometers away that is somewhat active. But it's not like violently active, or at least not in recent history. It probably you see steam or smoke coming out of it. I don't know, 2-3 times a week at least, maybe even more when we were there. And apparently lava maybe once every 2 or 3 years, kind of thing. So, but for a very, very brief amount of time. There's a much more active one about 250 kilometers south from there, although I haven't seen it at all in my travels. I've spent 4 months there in the last year and a half. So,
So which way the winds blow? They're coming in from the west, or they're coming from the east?
from the west. Yeah, prevailing winds are from the west.
So it's dropping all its moisture at lower altitude that's up now.
Yeah, actually, it rises very steeply from the coast. Like I'll show you a picture later. The VLT is only 15 kilometers from the coast, and it's at 8,500 feet or 2,800 meters. So it rises very quickly and then levels off, and there's a range or two in between. Yeah, that's one of the reasons it's so dry there. Is and also there's a number of factors. There's a current because there's a very deep trench right beside the coast that's about 6 kilometers deep. So there's a very cold current called the Humboldt current that runs up the west coast there, and basically it creates a permanent inversion layer there all the time. So almost all the moisture is kept out over the ocean and down below. The first time I went to the coast there, I didn't know all of this, and I was expecting, maybe a nice green coast it's desert right up to the waterfront basically. So it's really incredible. They do get marine fog that comes in a few kilometers in certain parts of the coast there, but like I said, it's only for a few kilometers, and even then it's still one of the driest deserts. So, the VLT, where I'll show you some pictures, when they were site testing and stuff there and doing climate data, it hadn't rained for 30 years. So, and since they built it, it's rained once a year. Since.
Where did they get their water, from the underground rivers?
Yeah, from the rivers, underground, wells.
They don't have any odd anomalies, like small sulfur lakes or different kinds of different types of.
Actually, you'll see there's salt lagoons there. It's not a source of drinking water, of course, but it does snow on the Andes here, and that melts every year and then runs down in the rivers and underground and stuff. But other than the oases, it's very, very dry. So this is a shot in the Valley of the Moon. There's very interesting geology in the area. So this is actually an old salt flat that was pushed up and crumpled. So these are all salt formations. Here's one of the salt flats. So you can see all the white. These are crystals of salt. Here's a close up. There's a little lizard. Not a lot of life, as you can imagine there. So here's one of the salt lagoons. So this is out in the flat. Very high salinity, so when you go swimming in it, you can't, you won't sink at all. Yeah, it's pretty amazing. Birds, and there are flamingos there. And here you can see the snow up on some of the peaks there. And they feed on crustaceans that live in the salt water there. Yep. Yeah, it's a really neat place. And here's a little fox. We saw him, actually, we're up at 17,000 feet here at the Alma site. So, we're not sure how he got up there in the first place, but we suspect he was being fed by the workers there. So, but so I don't know if he sort of followed them up or what. Can't imagine what he's hunting up at 17,000 feet. There's an impact crater about 2.5 hours south of where we're staying. And this is, from what I read on the internet, it's about 100,000 years old. And it's half a kilometer across and about 30 meters deep.
Was there any extinctions that you didn't find in the fossil record that correlate to this?
It's only 100,000 years old.
100,000 years ago.
Yeah.
But still, there would be, maybe in the strata, there'd be species that wouldn't be there after, very long after.
I don't even know if there's fossils that are 100,000 years old. I mean, that's not my expertise at all. I can't really.
Not astronomy.
Okay. So here's a map of the area. I got to visit. So here's Parnal, where the VLT is, and I'll show you some pictures there. This is Antofagasta. So this is a big port city right on the coast. Armazones is. I'll show you some pictures. There's just a very small, few small telescopes right there. But this may be the site of the 30-meter telescope. Right now, they're going to decide apparently in June or July, and they've narrowed it down to Armazones or Mauna Kea. So I guess the Americans really want it to go to Mauna Kea, but there's of course, if you're, what's that?
There's not enough room up there anymore.
No, and well, there's some legal issues and stuff as well. So I suspect it'll go to Armazones, but
What language do they speak there? Is it
Spanish, yeah,
Spanish?
Spanish.
Like some-
Yeah. Chilean Spanish.
Yeah, I was gonna ask you, like, you've learned some Spanish now over the last little while, you've been there long enough.
Yeah, I can't have a conversation, but I can get by. I can order things in the restaurant or that kind of thing. But,
So, my question was gonna be whether you, like, is it more similar to Mexican Spanish, more similar?
I don't know. I've never been to Mexico, so yeah, I can't really tell you. I mean, I've heard some things like, they drop certain things at the end of it, but I think for the most part, if you can speak Spanish, you can get by, and you don't have a big problem in Chile. It's not vastly different than any other Spanish, but I can't really say for sure. So here's Alma. So does everyone know what Alma is? If you don't, I'll show some pictures in a minute. So this is very close to where we are set up. And Chalanchar was a mountain that I visited as a potential site for one of the projects. That and Tolar. So these three, Tolar, Chalanchar, and Amazonas, were all very extensively tested for the 30-meter telescope. So they put seeing monitors there for 5 years. They had 30 years of satellite data that they analyzed. And they were all incredibly good sites. The reason they picked Amazonas of the three is its proximity to Paranal, and they'd be able to share facilities and stuff like that. So here's the VLT. So these are 4 8-meter telescopes. And they can be used as an interferometer, optical interferometer as well. And they have some outrigger telescopes. Everything, it's about 150 kilometers from anywhere, so everything that they have and need to work, they have to bring there, including their own power. They have a residence, and this is part of the residence here, which is basically a hotel, 140-room hotel. There's a pool, a cafeteria. It's really amazing place, indoor jungle in it. So here's a view of the VLT. Here you can see the coast here, so this is the ocean.
By the way, this is Steve just holding the camera over his head.
Yeah, no, I took this one off the internet, unfortunately.
It would take Steve to do
Yeah, yeah, it's easy.
Are each of these telescopes used for different purposes or different types of astronomy?
No, they're none of them are specific to a certain kind of astronomy.
For interferometry?
Yeah, they can be. Most of the time, I'd say one of them is being used with one or several of the auxiliary telescopes, which are basically 2-meter telescopes, and occasionally 2 of them are being used together as an interferometer. Most of the time, though, I would say it's probably at least 2 of them are doing completely independent stuff. So. Here's sunset from there. This is actually taken. Yeah, this is taken actually from Amazonas, and this is the Vista Telescope, which is a 4-meter telescope just on a close by mountain there. So here's the VLT, and there's Vista there. Just give you an idea. So this is taken from about 20 kilometers away. On my last visit there, I went. Les Nagy and Ivan Semenek came along as well, and they shot some pieces for the Discovery Channel that was on last week, the week before, I guess. So. And so I don't know if any of you guys caught any of those.
They're great.
Yeah. So we got an overnight visit at the Dark of the Moon there, and I got to take some pictures up on top. So that was really pretty amazing.
How long was that exposure?
That's a 1-minute exposure. The 15-millimeter lens.
So, are those just clusters of stars?
Yeah. So if you're not, this is the Southern Cross here. This is the famous coal sack. This is Alpha Centauri, Beta Centauri. Here's the bulge of the Milky Way. Yep, that's the large Magellanic Cloud. There's the small one there. It's just ducking behind. This is the Eta Carina Nebula.
Supernova 1987A.
Yes,
That was in the large.
that was in the large.
The large, right?
Yep. Discovered by a Canadian.
Yes.
In Shelton, yep. So, if you saw the pieces actually on Discovery, you'll have seen the time lapse. I'll show it to you later. But when you take a time lapse, you can also make star trails from all the images too. So this is a 5-hour star trail there at the VLT. And you can see where the South Celestial Pole is. So this is Armazones. So this is where they're doing the site testing for the 30-meter telescope, which Canada would be a 25% partner in if it gets built. This is the German hexapod telescope, which is on a nearby, slightly lower elevation mountain right there. It's a very interesting scope. It's in this structure, almost a pyramid shaped, and it splits in half and the two halves roll away. It's primarily solar powered, though they do have a diesel generator in case of cloud. Lots of batteries, yeah. That's a battery bank for sure. And here's the telescope itself. So it's a 1.5 meter mirror, and it has a very unconventional drive. These are actually 6 legs that can move, and they can point the telescope, rotate the telescope, and slew the telescope all at once. So I'm not sure the wisdom of it. They've been troubleshooting it for a long time, but apparently it does work when it works, but a lot of the time it doesn't work. So. And I think it's just mechanical issues that they have problems with. But I had to take a picture of it because it's such a unique telescope. I'd never even heard of anything like it before. So it's definitely interesting. And we got a tour and a demonstration when I was there, so that was pretty neat. So this is back near San Pedro. So I'm just going to point out. So here's the town itself here. Apex and Alma. Alma is the Atacama Large Millimeter Array. So this is going to be an array of 66 12-meter dishes in the millimeter array. Apex was basically a test instrument, same size telescope there. You can't see it, but ACT is also here, the Atacama Cosmology Telescope, which was actually built in Canada. Here's a picture of it here. So over here, this is where we're staying, down here in the oases here. We actually drove all the way up here. So ACT is at about 17,000 feet. We're probably almost 500 or 600 feet above that here. You really feel altitude at 17,000 feet. You have half the atmosphere that you have at sea level. So walking up any kind of even gradual incline, you get out of breath. A steep incline, your head is pounding like you wouldn't believe. It's really amazing. The color of the sky is just incredible. There's none of the junk or haze or dust or anything. It's really amazing. And the reason they're building all the millimeter telescopes at this height is the water vapor. You have to be of about 4,000 feet, 4,000 meters to really knock down the water vapor in the wavelength range they're looking at. So here's a close-up of the ACT. So here's Alma. This is actually taken from one of the roll-offs at Alain's place. So this is about 50 kilometers away, 40 kilometers away. And this is at about 3,000 meters. and this is the assembly station. You can just see some of the dishes that they're putting together. So here's a cropped version of the same image. Here's some of the dishes there. We got a tour there on our last visit there a few weeks ago. This is one of the, I think it's one of the European dishes. It comes in 2 halves on trucks, and they were going to take it up to the assembly station. And here's some of the completed dishes. These are North American ones. So these are 12-meter dishes. And like I said, there's going to be 66 of these, and then they'll be taken up to altitude, and they'll be used in a large array. I think up to 16 kilometers across is the maximum diameter.
These dishes would be how many meters?
They're 12 meters. Yeah.
What did you say they're accurate within 15 microns? So
Yeah, the spec was 15, and these ones, I think they were saying they were getting 11. The surface was accurate to 11 microns.
Oh my God.
Yeah, which is really amazing.
Oh, it really is.
And they needed them to be at least 15. That was the spec on them. Yes?
Yeah, I need to go soon, so I just want to
Sure.
ask this question. Now, are they putting up a lot of these telescopes in Chile, in this area, because of the altitude and the clear skies?
Yeah.
Or do you know of other places in South America or the Southern Hemisphere that they're putting up some of these telescopes?
No, almost everything is being done in Chile. There are a few places in Argentina. Chile has much better weather for the most part. And this Chinantar Plateau where they're building Alma is unique in that it's very high. It's 5,000 meters or 17,000 feet. And they have a very large flat area
You wouldn't know of
that they
any,
can do it.
like, just in the whole Southern Hemisphere, like Africa or Australia, where else is there?
In the south.
Oh, sure. There are observatories in Australia. There are some in South America. In the south of Africa. The climate in Chile, in the Atacama Desert, though, is so much more favorable over any other place in the world. I mean, it's really the premier spot for anything to be built these days. I mean,
So when they're looking for things, it just depends where they're being done.
yeah, I mean, there are three very large telescopes that are sort of being developed right now. The giant Magellan telescope, which will be for sure located in Chile at Las Campanas. It's a 24.5 meter. So they've said they're going to build that one there. The 30-meter telescope, like I said, they're going to decide in the next month between Chile and Mauna Kea. And then there's the European extremely large telescope, which would be 42 meters, and it almost surely will be built in Chile as well. So.
Radio astronomy, though, it doesn't matter how high elevated
For this it does, because they're looking in the millimeter wavelength, so they need the water vapor to be very low, so it makes a huge difference, even from 4,000 to 5,000 meters, so they definitely have to be at a very high altitude. So.
Steve, what about the wind out there? Is there a lot of wind out there?
There is some wind. Surprisingly, it's surprisingly light compared to a lot of other places I've been. So it's definitely a good spot. But I mean, of course, at any kind of altitude on an open mountaintop, you are susceptible to wind. But I suspect the winds at the VLT are probably higher than at Alma. So this is one of the carriers for the dishes. So they use these to move the dishes around and to transport it to the top of the mountain. So if they're going to change the configuration of their array from a small compact one to a large one out, this is how they'll move it. Each dish actually has to be positioned to within I think a couple millimeters. So it's really incredible, the tolerances. And they have basically a kind of jig that they put into the permanently into the each pad where they're going to have these dishes. I think there's going to be 200 different pads, so for the 66 dishes. And then there's a much more modest observatories and projects that I've been working on there. So on our first, this is a picture from my first trip down there. So we shipped actually a couple of roll-off buildings down there. I had them, at least the walls were prefab. These are actually sky shed roll-off observatories, 10 by 12s. And we didn't know if we were going to stay, what the plan was. So I figured if we screw everything together, if he doesn't like it, if we're not staying, they can all go back in the container and get shipped back. Of course, as you may have guessed, they've stayed there since. But these were assembled there. We had some piers built. This is a Paramount with a 20-inch plane wave, or so 0.5 meter. Then so then we took it down, started building the observatory. These went up fairly quickly, probably in a couple of days each. So even though the walls were prefab, we still had to do the roofs and the floors. So these were both built. There's two of them on my first trip there.
And what was the location again? This is at the...
This is at San Pedro.
House?
Yeah. So they are to be temporary structures, although now they're going to remain permanent. And what we're actually done is build. This is the prompt. So this is a. I can't remember what the acronym's for, but basically they're looking for follow-ups to gamma ray bursts. And essentially they're using basically the same equipment we're going to be using, so sort of 0.4 to 0.5 meter telescopes in clamshell domes and the fully robotic. We were going to buy them from Astor Haven, but we had all kinds of problems with them I won't get into. So we decided we would make our own. So I had them designed up. We changed a few things for shipping, so this will actually be split in half, and it reduced the cost both for shipping and for manufacturing and the number of molds you need. So I found a place in Niagara Falls to make the molds, and then a place in Hamilton to actually do the fiberglass work. So these are fiberglass molds for the pieces. So here's some of the dome pieces being constructed.
Now all this is happening here.
Yes, well,
And these pictures are taken
yeah, these were, yeah,
before you ship the parts down.
that's right, yeah. So these actually just left a couple weeks or a week and a half ago. So there's a completed dome. So 3 of these just shipped down. We also decided to build some telescopes as well. So Star Instruments, that makes the optics for RCOS and OGS. They had some surplus astrograph, RC astrograph optics. So we decided to buy those optics and build our own telescopes from them. So we had these designed up. Here's a back plate and mirror cell for the, I think this was for the 20-inch. And then there's the completed 12.5-inch. There's the 20-inch in Chile. So this was installed on my last visit there. And on my next visit, it'll go into one of the clamshells. And here's a shot of it at night. Bulge of the Milky Way. So I'm going to talk a little bit about some of the current projects that we're working on there. There's a wide field search project for comets, nova, near the Earth objects, etc. An M-dwarf project, which I'll get into more detail on, and then a 0.85 meter that will likely be in Hawaii. So the wide field search, our object will be to image the sky to Mag 16 several times per night using 8 200 millimeter Canon photo lenses, so sort of like the Super Wasp. I've got a picture of that here. So this is the Super Wasp setup. So these are 8 lenses, and they're all aimed at a slightly different part of the sky, sort of all like a big mosaic. So you can take 8 frames. You can get roughly 400 or 500 square degrees per 8 images.
What cameras are you using?
We're still deciding right now. We were first looking at Apogee U42s. We may try, we won't be quite as stringent with the photometry that we need. So we may try one of the QHY11s or something like that if they ever become available, or SD11000 or something. It might give us more bang for the buck. Also in terms of imaging area as well. So.
You have a red dwarf study.
Yes.
They use infrared or not for that, wouldn't
Yeah, that's what we're doing. Yeah.
they?
Yeah. So, and we're definitely using the Apogee cameras for those. So we're going to search for two Earth or Earth mass planets around M dwarf stars. So these are these are red dwarf stars. They're all typically very faint, very close stars to our solar system. So I'll talk a little bit about the different detection methods, and then specifically some of the methods that we're going to use. So there's direct imaging, astrometry, radial velocity, pulsar timing. These are all methods that either can or have been used for detecting planets around other stars. So of course, most people think of it first is, can you actually directly image, and only very recently has this been proven to be the case. Using here they've used a mask around formaldehyde. This is an HST image, so they've actually directly imaged planets doing that method. And I'm sure now that they've proven that it's done, more and more people will be trying and stuff. But you know, you can't get too close into the star. Each method has its pros and cons, and but you know, we live in a very exciting time. It was only 10, 15 years ago that the first exoplanets were proven to exist. So astrometry would be certainly possible, although it hasn't been done yet. I think Hubble has confirmed on some, maybe 1 or 2 that it's possible to do. You have to do this from space, basically. But anyway, the method basically involves looking at the wobble of a star caused by an orbiting planet. And this is different from the radial velocity wobble. This is actual visible light wobble that you'd be looking for. So you'd be looking for the change in position back and forth of a star, but the numbers and the tolerances are very, very, very high. So you need space basically to do it. Radial velocity. So this is the one probably most people are familiar with, and by far this has been the most successful method. Probably 80–90% of the systems so far have been found using this method. So what you're doing here is that you're looking at the spectra of a star as a planet rotates around it. So it will actually cause the star to either move a little bit away or a little bit towards you as it's orbiting. So it tugs on the star, and then if they study, if you take a spectra of the star, then you can see the Doppler shift. It works for systems where the planet is along our line of sight. If it's a face-on system, it doesn't work at all, because then there's no back and forth wobble towards us. Pulsar timing. So here they're doing very, very accurate measurements of the timing of pulsars to look for exoplanets. Actually, the first ones in, I think it was 1995, were discovered this way. But there are relatively few pulsars to observe, so your odds of success, of course, are very low. Then this is probably the most interesting, especially for amateurs, is the transit method. So if we happen to have a system that lines up along the Earth's line of sight so that the planet actually passes in front of the star as viewed from Earth, then every time it passes in front of the star in its orbit, it'll actually block out a little bit of light, and you can measure this dip. And it works out to be between 1% and 3%. And this is certainly doable even for amateurs. And there's probably been about 30 or 40 discovered this way. The nice thing about this method is, of course, you need radial velocity to confirm that it's actually a planet, because there are other possibilities, blended star, brown dwarf, that kind of thing. But once you have the light curve and you have the radial velocity measurement, then you have a complete solution for the mass, the bulk density, everything in the system. So it has some great advantages that way. Here's a field of a known exoplanet that we did. We made an observation. Unfortunately, the transit continued after daylight, but a couple of weeks later we got it again, and so you can actually see the dip here from a known transit.
Whose data is this?
This is our data. So this was a known. So this is discovered by the Corot spacecraft. So this is Corot XO2, and so I knew, when, there's an ephemeris out there, so I actually knew when the transit would occur. You start several hours before, you follow it right through. So.
And what's the scale on the y-axis?
This is probably, it doesn't show up on here. So this is about 0.03 magnitude dip, I guess. So.
0.03.
Yep.
In southwestern Ontario, due to changes of haze, clouds moving in, you'll get 3 magnitudes of change in the course of an evening.
But you're doing differential photometry, so
Yeah.
you're presumably your reference stars are going to be dimmed by the same amount. So.
But was this done here or in
No,
Chile?
this was done in Chile.
Yeah.
Yeah.
And are the crosses actual error bars or merely representing?
No, they're
where the point is?
they're just error bars on there. So.
How long did it take the whole transit time on?
I think this is about 2 hours.
Who's funding this?
That's a good question. It's a private individual, actually. So another method that is being used is gravitational microlensing. So here you have an observer here on Earth. You look at a source star. So this is a star far off in the Milky Way. And then what you're looking for is a brightening due to an intervening planetary system, or a star and a planet. So if it's just a star, you'll get a curve like this. If there's a star and a planet, you'll get an anomaly in the curve. And there's probably been about 8 or 10 planet systems being discovered this way. And there's a few programs. One is OGLE. I forgot what the acronym is. And basically, they're looking at millions of stars every night, monitoring them, and then they send out an alert that there's an event, microlensing event beginning, and then they make a call out for a global network of professional and amateurs to study the event and to take photometry on it, and then you submit the results, and hopefully they find planet system. There's a site called Microfun, which is the amateur collaboration with it. It's like I said, they've found about 8 so far doing this method. So, and this is something amateurs can get involved with as well. Polarimetry. So, only briefly going to touch on this because this is likely what one of the scopes, the 0.85 meter, will be used for. So starlight becomes polarized when it interacts with an atmospheric molecule around a planet, and then this can be detected with a polarimeter. Don't ask me any details on it because I don't really know. It's likely going to be on Haleakala in Hawaii. And here's the scope itself being constructed. There's the blank here. That's actually the mirror is almost finished right now. I think it's being coated. So this is a 32-inch or 0.85 meter Ritchie Chrétien. And then I have some pictures of the night sky from my trips down there. I think it's about 1 day. So, and here it is right here on the horizon. So really amazing. So here's the Milky Way on the horizon there. And here's the small and large Magellanic Cloud. Eta Carina. This is looking east. This is the winter Milky Way. Here's Orion. Pleiades.
Put our arms upside down.
Right. There's the light pollution I was talking about. So this is zodiacal light through the bulge in the Milky Way. So this is looking west just after sunset. Probably in October, I think. Orion and north south. These are mostly digital SLR shots. So this is a 2-minute exposure. This is the Coalsack. Here's the Southern Cross. This is taken with a 135 millimeter lens. 2 minutes. Was that nebula? It's a 200 millimeter shot of M17 and M16, M24. Summer Milky Way stuff. Swan Nebula. This is taken with actually with a hyperstar and 40D, stock 40D.
Do you know how far away the Swan Nebula is in light years at first?
No.
No.
Bob Douglas on it.
3,000-4,000, I'm guessing. Eta Carina. This is magnificent nebula. This is about 3 times the diameter of the Orion Nebula as seen from Earth. Really blatantly obvious naked eye object. There's a close-up of it. Incredible detail, knots and stuff. This with the 20-inch. This is just the central portion now. Dust clouds.
Have you thought of comparing this with older images to see if you can detect the movement of the expulsion cloud?
I have not, actually. That would be a good idea. Actually, did you see Doug Welch's talk at Starfest?
I wasn't at Starfest, actually.
Or to
Light
anybody's?
echoes?
The light echoes, yeah.
Yeah.
So In September, October, when I was there, I did a 100-frame mosaic in this area, and then I did another one on my last trip there. I'm not difference to image them yet, but that will definitely be one of the things we do. But
You're
I mean,
looking for
that'll
the
only
light
be
echo
6.
of the burst back in the 18...
Yeah, or any ones that haven't been not known about yet or
Right.
anything, right? So,
Right.
yeah. So this is the small Magellanic Cloud and another naked eye globular cluster. This is 47 Tucanae. And there's the large cloud. This is the Tarantula Nebula. In a telescope, that's there are no pictures that do that justice, but it's a really amazing object to look at in a telescope.
Is there color visible?
Yeah, kind of a greenish.
Like Orion.
Yeah, you don't see the red for sure. Definitely more green. So here's the center bulge of the Milky Way. Here's Jupiter. These are 4 1-minute exposures taken with the 28 millimeter lens. And here's the one of the horizons here. This is the cat's paw. These are the stinger stars in Scorpius. It's an amazingly rich area. And of course, in Chile, this passes straight overhead.
Yeah, I was just going to say, here we can see
So
that.
we're at latitude minus 23 in Chile. So
It's M7 and 6 then just over there.
yeah. And so here's another view of it. There's this other nebula. I forget what it's called. Somebody probably knows.
False comms.
M8, Lagoon Nebula, and the Trifid. These are all single 2-minute exposures, a 200 millimeter lens. This is the close-up with the C14 with the hyperstar. This one's called the running chicken. I don't know who named that or anything, but it's very interesting. So this is near Carina.
If I may, Swan Nebula is just over 5,000 light years away.
Right. See, I told you there was a know-it-all in every cloud. So here's the Tarantula Nebula. So this is in the Large Magellanic Cloud. This is taken with the 0.5 meter digital SLR. The picture doesn't do justice to what you can actually see with your eye. Row of UK region. Those M4. Shot of the Lagoon. Galaxies, this is NGC 253, which you can actually see from Canada, but it's,
Oh, yeah, it's
low.
pretty low, but still, it's enjoyable.
Over there.
What was this shot done with?
This is done with the 0.5 meter. This is done with the C14. Rosette. This is Omega Centauri, rather naked eye globular, but third magnitude. What's that?
Actual size.
Actual size, actual size. Yeah. Actually, I like 47 Tucanae better. It's, has a very colorful core and stuff. both spectacular objects for sure. The horse head in the flame. The horse head. This is Comet Mcnaught, but not the famous Comet Mcnaught. So this was one that happened to be visible when I was down there. It got to about 6.5, 7 magnitude. It's quite a nice little object. Helix. What's this? 4945. Interesting spiral galaxy. It's M83. This was taken with the new 20-inch.
So, what are you operating at, focal length wise on these?
Both the 20 inches are actually about 6.8, 6.9. That's about 3,500 millimeters. Color image. 2997. There's a 253. See 300, I think.
And these are all on the software disk mount.
Yes, these are all in the Paramount. They've worked very well. So we're actually operating remotely. We installed high-speed internet. So.
This one here looks as if it's a galaxy collision.
No, this is a
It's a
barred spiral.
Barred.
As you see, 1365. And this is NGC 55. Yes, it reminds me a lot of M82, except without the red streamers coming out of it. Very similar, lots of interesting dust details. And this is a very deep image of the Large Magellanic Cloud with a 200 millimeter lens. This is a